Hello, magandang araw sa lahat. So, welcome to the very first uh, video lecture for our subject. So, in this particular video, we'll just have an introduction to differential equations. So, di-discuss muna natin yung mga basic terminology na kailangan ay familiar tayo bago tayo pumunta dun sa pinakapakay natin sa subject na to, which is kung paano mag-solve ng mga differential equations. So, ano nga ba ang isang differential equation? Okay, so napakasimple ng definition na to. A differential equation is an equation containing the derivatives of a function. So, meron tayong mga examples dito. Okay. So, I have here y prime. So, at the same time, we're also recalling yung iba't ibang notation natin for derivatives. So here I have y prime equals y. So here I'm using the prime notation to denote the first derivative. So this is a very simple example of a differential equation. So dito naman, I'm using the dy dx notation. So on the first term on the left side, I have the second derivative of y with respect to x plus dy dx plus sine x equals 0. So kung gagamit ako ng y prime notation, itong itong second equation natin, pwede ko siyang isulat as y double prime plus y prime plus sine x equals 0. Ito namang pangatlo, okay, if you recall, this notation is the notation for partial derivatives. So I have partial y partial r plus 2 partial y partial x equals x. Okay. So in this case, compared dun sa pangalawang naunang example, meron tayong partial derivative. And of course, partial derivatives appears when yung pinaka-function natin, which is y, is a function of 2 or more variables. Okay. So this is also a kind of differential equation. Ito namang fourth example natin. This is another notation for partial derivative. So here, the function is f. Okay? In this notation, if we still remember, itong f sub xz, this means that we're taking the partial derivative of f with respect to x, and then saka natin kukunin yung partial derivative with respect to z. Okay? So, ang pinaka-goal natin sa subject na ito is to find solutions. So, to solve differential equations. And what do we mean by a solution? So, a solution to a differential equation is a function that satisfies the equation. Okay. But for this particular course, Math 121.1, ang may encounter lamang natin ng mga differential equation na kailangan natin i-solve ay yung merong ordinary derivatives katulad nitong first two examples. So partial derivatives, hindi siya covered ng ating course. So let's look at a simple example. Okay. So let's solve the equation dy dx equals cosine x. Okay. So, madali lang itong i-solve. For this example, ang kailangan lang natin gawin is i-integrate yung both sides ng equation with respect to x. So, I will integrate both sides. So, on the left side, meron akong integral ng dy dx and dx. And on the right side, I have the integral of cosine x dx. So, meron tayong integral sa kaliwa, meron din tayong integral sa kanan. Those will produce their own constants of integration. But actually, pwedeng isa na lang yung isulat natin. For example, yung sa kanan. Since anyway, itatranspose din naman natin yung constant of integration na yun. So, dito sa kaliwa, i-integrate ko siya, pero hindi ko na isusulat yung constant of integration. So, yung integral ng derivative ng y, of course, is just y itself. And then, ang integral ng cosine x dx is sine x plus c. So, ito na ngayon yung solution dun sa differential equation natin. So, as you can see, meron tayong na-produce na constant of integration. So, ibig sabihin, hindi unique yung solution natin. So, for any value of c, which is a constant, y equals sine x plus c will be a solution to this equation. So, we actually have infinitely many solutions for this equation. So you might be wondering, if we have a differential equation, ito lang ba yung kailangan natin gawin? Do we have to just integrate both sides? So actually, hindi. So there is a class of differential equations na nasusolve natin by simply integrating both sides. Pero hindi lahat. Okay. So of course, we will go to those types of differential equations in the next upcoming lessons. Okay. 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 So why are we studying differential equations? So suppose you're observing a certain mathematical phenomenon and it involves some quantity na nagbabago. So for example, you're observing the population of a certain organism in a certain area, or maybe you're observing the distance that a certain object has traveled. Okay. So most of the time, hindi natin alam agad yung function that gives the quantity that we want. But, alam natin describe yung rate of change ng function na yun. Okay. And this is where differential equations come in, because the derivative has a natural interpretation in terms of rate of change. So let's look at this example. Okay. This will be familiar from Math 83. Okay. So suppose we have an object dropped from a height of k meters and it accelerates at a constant rate of negative g meters per second squared. Second squared dapat ito. Kasi acceleration to. So an object dropped from a height of k meters accelerates at a constant rate of negative g meters per second squared. So find the function s of t that describes the object's distance from the ground at time t. Okay. So suppose ito yung object natin, ito yung ground, and then it was dropped from a height of k meters. Yeah. So of course this object is going down. Okay. So ang alam lang natin is it accelerates at a constant rate of negative g meters per second squared. Okay. So gusto nating malaman at time t ano yung distance niya from the ground. So let s of t be so ito yung gusto nating malaman, distance from the ground. Distance from the ground. Time t. Yeah. You will recognize this from Math 83. This is just the position function. Okay. So, hindi natin alam yung position function at first, but we know how the rate of change in the position function relates to the quantity that we know, which is the acceleration. So, if we denote acceleration by a of t, the acceleration function by a of t, then it will be equal to negative g. And we know that acceleration is the derivative of the velocity function. So dv dt is equal to a of t. And we know as well that the velocity function is the derivative of the position function. So ds dt is equal to v of t. So we can go from acceleration to velocity, and then from velocity to the position function. Okay, so let's write our equation, our differential equation. So meron tayong dv over dt is equal to negative g. So again, katulad nung ginawa natin sa first example, all we have to do is integrate both sides. Okay, so integral of dv over dt with respect to dt is equal to the integral of negative g dt. Okay, on the left side, I have the velocity function. And I'll just write this as v. Most of the time, yung mga function natin, hindi na natin isusulat yung independent variable nila kung understood na from context. So sometimes I will write acceleration, the acceleration function as a, and the velocity function as v. So v is equal to negative g t plus c. Let's call this c sub 1 since nag-expect tayo na makakaproduce tayo ng isa pang constant of integration when we integrate itong pangalawang equation natin. Okay. So next, I'm going to write v as the derivative of the position function. So v is equal to ds dt, and that's equal to negative gt plus c sub 1, and then I will integrate both sides. So integral ng ds dt with respect to dt is equal to the integral of negative gt plus c sub 1 dt. Okay. So on my left side, I will now have the position function, which is s, and on the right, I have integral ng negative gt, which is negative g t squared over 2 plus c sub 1 t plus c sub 2. And there you have it. We have solved the differential equation. We solved the problem by writing it in terms of differential equation. And this is now the solution. Okay. So meron tayong constant c sub 1 and c sub 2. Now we need to resolve those constants. So ano yung interpretation natin for c sub 1 and c sub 2? Ngayon, kung babalikan natin itong expression natin for the velocity, yan. This is the velocity function. If you evaluate this at t equals 0, okay, so v of 0 is equal to, matitira, makakancel itong negative gt. So, c sub 1 na lang. So, ano ibig sabihin nito? Ibig sabihin nito yung c sub 1 natin is just the initial velocity. But from the problem, sabi dito, the object was dropped. So, it was simply dropped. Okay. So, hindi siya binato. So, binitawan lang siya. So, ibig sabihin nun, yung initial velocity ng object natin ay 0 lang. So, c sub 1 is 0. Okay. Now, what is now the interpretation for c sub 2? Okay. So, if we evaluate the position function at 0, so s of 0, ang mangyayari, so makakancel itong first term. Ganun din, itong second term, makakancel din. Ang matitira ay c sub 2. So, ano ibig sabihin nun? Yung c sub 2 natin is just the initial position. Okay. But the initial position is given. It's equal to k meters. So, therefore, c sub 2 is equal to k. So, pwede na natin ngayong masulat yung ating final solution. Gamit ako ng blue. So, the function now, which describes the object's distance from the ground at time t, is given by s, which is equal to negative g t squared over 2 plus c sub 1, which is 0. So, makakancel lang to. Itong pangalawang term. And then plus c sub 2, which is equal to k. Okay. So, ginamit ko lang tong familiar na problem na to involving rectilinear motion from Math 83 to illustrate the fact that minsan hindi natin alam yung function na nagdi-describe nung phenomena na gusto nating malaman or maintindihan. Pero alam natin yung mga derivative that involves that function. So let's look at another example. Okay, so here I have so the rate of change in the growth of bacteria in a petri dish is directly proportional to the current number of bacteria present. So suppose merong isang biologist and he was tasked to count the number of bacteria that is growing in a petri dish, and he made this observation. So yung rate of change in the growth of bacteria is directly proportional to the current number of bacteria present. So, ano ibig sabihin nun? So, ano yung rate of change in the growth of bacteria? Rate, wait lang, gamit ako ng black. And black. So, rate of change. Okay. So, rate of change is of course just equal to the, suppose itong number of bacteria natin is given by P of T. So, it will be P at a future time T plus 1 minus the current number of bacteria, which is P of T, divided by, so this is ito yung change in population divided by change in time. So, change in time is just T plus 1 minus T. Okay. Since yung T natin is in hours and ang increments niya ay 1 lang, so we have T plus 1 minus T. So, we actually just have P of T plus 1 minus P of T. Okay. But, just for illustration purposes, I'm going to write this. Okay. Suppose iba yung increments ng time ninyo, hindi 1. We're going to write P of T plus 1 minus P of T as delta P. And then yung change in time naman will be delta T. Okay. So that's the rate of change. Okay. So, ang na-observe nung biologist natin is yung rate of change, which is this. So, delta P minus delta T is directly proportional or approximately directly proportional to the current number of bacteria present. So, if a certain quantity is directly proportional to another, ibig sabihin, yung first quantity is equal to a constant multiple of the second quantity. Okay. So, rate of change, ito yun, is directly proportional to the current number of bacteria present. So, ibig sabihin yung delta P over delta T natin is equal to some constant K times the current number of bacteria present, which is just the function P. Yan. Okay. So, you might be wondering how the biologist actually made this observation. Well, if you look at this, so let's do some computations here. We can actually estimate the value of K. So, K is just equal to delta P over delta T divided by P. So, let's do some computations here. Let me just open my calculator. Okay. So, when T is equal to 1, ayan, yung delta P natin, of course, yung delta T natin is just equal to, is just equal to 1. 1 lang to. So, delta P will be 503 minus 300 divided by 300. So, that's equal to 0.3979. So, at T equals 2 naman, okay, so we have 824 minus 503. So, 824 minus 503 divided by, sorry, this is supposed to be ano, yung sa first equation natin. This is supposed to be 503. Okay, so 824 minus 503 divided by 824. Okay, let me just compute that. So 824 minus 503 divided by 824. That's 0.3896. Okay, so you can actually do that with all the other values for t. And so ito yung na-observe nung biologists natin. Yung value ng K is always close to 0.4. Okay, so K is actually approximately 0.4. So we have delta P over delta T is equal to 0.4 P. So how do we translate this in terms of a differential equation? Well, ang mangyayari, we'll just let delta T go to 0. Okay. So if we let delta T go to 0, itong delta P over delta T natin will just become dP over dt. So dP over dt is, I'm using equals, but of course, this is an actual observation, an experimental observation. So approximation lang ito, but the approximation is quite good. So this is, the numbers that we get are very close to 0.4. Okay, so dP over dt is equal to 0.4 P, and this is now the differential equation that we want. So unlike the previous examples that I gave you, hindi nyo ito masasolve just by integrating both sides. So we need another technique, and that will of course come in the next few lessons. Okay, so some additional terminology. Okay. So the order of a differential equation is the largest order of the derivative that appears in the equation. Okay. So yung order, yung pinakamataas na or pinakamalaking order ng derivative na nasa equation. Okay. So a differential equation is called an ordinary differential equation, or ODE, if it only contains ordinary derivatives, and a partial differential equation, or PDE, if it contains partial derivatives. And of course, this subject is only concerned with ODEs. Okay. Okay, so let's look at this example. So determine the order of the following differential equations and identify whether they are ODEs or PDEs. So ito yung example natin kanina. So y prime equals y, we only have the first derivative. So this is of order 1. So this is of order 1, and this is an ODE. Dito naman, sa pangalawa, meron tayong second derivative. So this is of order 2, and it is also an ODE. And sa pangatlo, we have both first derivatives. So partial y over partial r, that's order 1, and partial y over partial x, order 1 din siya. So order 1 lang itong equation natin, and this is a PDE. And then we have this. So ito, nag-differentiate tayo ng dalawang beses. Dito rin, dalawang beses. Also here. So 2 yung order nito, and we have a PDE. Okay. 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 So the general solution to a differential equation is a solution containing arbitrary constants. So dun sa example natin kanina, if you recall, nung sinolve natin yung problem involving rectilinear motion, ang nakuha nating value ng acceleration, which is equal to negative, ang nakuha nating position function rather, is s of t equals negative gt squared over 2 plus c sub 1 t plus c sub 2. So we have arbitrary constants, c sub 1 and c sub 2. So this is a general solution. So, general solution to what equation? Well, yung original equation natin is a equals negative g and a is the second derivative of s. So, ito yung differential equation natin. D squared s over dt squared is equal to negative g. So, this is a general solution to this equation. So, paano natin na-resolve yung values ng c sub 1 tsaka c sub 2? So, ginamit natin, para ma-resolve yung value ng c sub 1, ginamit natin yung value ng velocity at t equals 0. Okay. So, of course, that's just equal to s prime of 0. And yung c sub 2 naman, na-resolve natin by the initial position, which is equal to s of 0. Okay. So this will now motivate my next definition, which is the definition of an initial value problem. So an initial value problem is a differential equation of order n. Okay. So we have a differential equation of order n together with n initial values. So dun sa problem natin kanina, meron tayong, so ito yung differential equation natin. This is of order 2. And we have two initial conditions, which are the value of s prime of 0 and the value of s of 0. Okay. So again, an initial value problem is a differential equation of order n together with n initial conditions. So these are the specific values of the n minus 1 derivative, n minus second derivative, hanggang dun sa value nung function mismo. Okay. So, let me just write again yung problem natin kanina. So, we have d squared s over dt squared is equal to negative g. And we have initial values. So, here ang order natin ay 2. So, we start with order n minus 1, which is 2 minus 1, so 1. So, s prime of 0, so equals, so some value, and then s of 0 equals some value. Okay. So, this is an example of an initial value problem. Okay, so let's look at this example. Okay. So let's verify that c sub 1, y equals c sub 1 e raised to x plus c sub 2 e raised to 3x is a solution to this equation. So y double prime minus 4y prime plus 3y equals 0. Okay. And find the values of c sub 1 and c sub 2 using the initial values. Y prime of 0 equals 0 and y of 0 equals 1. And then write the solution to the initial value problem. So ito yung equation natin. Y double prime plus 4y prime plus 3y equals 0. Okay. Now in this case, binigay na yung solution. We just need to verify na solution nga siya. Okay. So again, what do we mean by a solution? Ibig sabihin, kapag pinag-in natin ito dito sa equation natin, it will become a true statement. So kapag plinagin natin yung y dito sa left side, dapat ang result niya 0 din. So compute muna natin yung value ng y prime. So y prime is equal to c sub 1 plus, kailangan natin mag-chain rule dito sa second term. We have 3 times c sub 2 e raised to 3x. And then y double prime, sorry, nakalimutan ko yung e raised to x. So dapat meron tayong e raised to x dito. Okay, on y double prime naman, we have c sub 1 e raised to x plus 3 times 3, so that's 9, c sub 2 e raised to 3x. So ipa-plug in lang natin itong y prime tsaka y double prime dito sa equation na to. Kailangan 0 yung makuha natin. So I have y double prime, so c sub 1 e raised to x plus 9 c sub 2 e raised to 3x minus 4 y prime. Ito yung y prime natin. So c sub 1 e raised to x plus 3 c sub 2 e raised to 3x plus 3 times y. Ito yung y natin. So c sub 1 e raised to x plus c sub 2 e raised to 3x. So dapat pag sinimplify natin to, 0 yung makuha natin. So i-distribute muna natin yung mga constants na nasa labas ng parenthesis. So c sub 1 e raised to x plus 9 c sub 2 e raised to 3x minus 4 c sub 1 e raised to x minus 12 c sub 2 e raised to 3x plus 3 c sub 1 e raised to x plus 3 c sub 2 e raised to 3x. So 0 nga ba to? Combine natin lahat ng mga may e raised to x. Okay, so ito yon, ito, and then ito. So c sub 1 minus 4 c sub 1 plus 3 c sub 1 is indeed 0. So 0 e raised to x. And then yung mga may e raised to 3x naman, ito, and then ito. So 9 c sub 2 minus 12 c sub 2, that's negative 3, plus 3 c sub 2, which is 0. So indeed, 0. So therefore, this function here is indeed a solution to the equation. So we're done with the first task. Next task. Find the values of c sub 1 and c sub 2 using the initial values. Y prime of 0 equals 0 and y of 0 equals 1. Okay. Let's start with y prime of 0 equals 0. So ito yung y prime natin. So y prime of 0 is equal to, so mangyayari magiging e raised to 0 ito, which is equal to 1. So c sub 1 na lang siya. Plus, ito rin. Itong e raised to 3x, magiging e raised to 0. So 1 din yun. So matitira ay 3 c sub 2. And according to here, this is equal to 0. Ngayon, gamitin natin itong y of 0 equals 1. Okay, we're going to use the function, the solution, the given solution. So y of 0, so again, yung mga exponentials natin magiging 1 lang din. E raised to x will become e raised to 0 and e raised to 3x will become e raised to 0. So y of 0 is equal to c sub 1 plus c sub 2, and this is equal to 1. Okay. So we actually have a system of linear equations, two unknowns. Okay. So one way to find the values of C sub 1 and C sub 2 is we can eliminate one of either C sub 1 or C sub 2. Okay. So, pinaka-obvious yung C sub 1. So, eliminate C sub 1, I will subtract the second equation from the first. Okay. So, I will get, so C sub 1 minus C sub 1 is 0 plus 3 C sub 2 minus C sub 2. And I get 2 C sub 2. And then 0 minus 1 is equal to negative 1. So that means C sub 2 is equal to negative 1 half. Okay. Now I can either use the first equation or the second to find the value of C sub 1. Pero pinaka-simple yung second equation. So according to the second equation, I have C sub 1 plus C sub 2, which is negative 1 half, is equal to 1. And that means C sub 1 is equal to 1 plus 1 half, or 3 over 2. Okay. So we can now write the solution to this initial value problem. So given yung solution, and we also have now the constants. So the solution now is, ulit ko dito, y is equal to C sub 1, which is 3 over 2 e raised to x, plus C sub 2, which is negative 1 half. So negative 1 half e raised to 3x. So for now, for this example, given yung solution, but eventually we will be able to solve this kind of differential equation on our own. Okay. So let me box the final answer. Okay, so definition. So an explicit solution is any solution of the form y equals y of x. Okay. So if our solution is y as some function of x, for example, x squared plus c sub 1x, then that's an explicit solution. So another example is yung meron tayo kanina, yung sa position function. So s is equal to negative gt squared over 2 plus c sub 1 t plus c sub 2. So in this case, yung independent variable natin is t, which stands for time. So this is our examples of explicit solutions. And then yung kanina rin sa previous, yung sa IVP, ito. So this is an explicit solution. Now, sometimes there will be cases na hindi natin masosolve yung mismong value of y. What we have is just an expression involving y. In that case, what we have is an implicit solution. So for example, so this is our implicit solution. As you can see, it's not y equals a function of x. We have an expression in terms of y. So this is an implicit solution. So let's show that this is an implicit solution to this equation. So how do we do that? Kung meron tayong explicit solution, all we need to do is plug in. But in this case, we have to do something else. So ang gagawin ko dito is I will get the derivative of both sides of this solution. So derivative of y squared is 2y y prime, and that's equal to derivative of x squared minus 3, which is equal to 2x. And then I will have to manipulate this expression para makuha ko to. Okay. And then ang gagawin lang natin ay i-divide yung both sides ng 2y. So I have So, cancel yung 2y. I have y prime is equal to, sa kanan naman, cancel yung 2. I have x over y. So, this is just a simple example of an implicit solution and how to show that that implicit solution is indeed a solution.